So on CP1-3, we are calculating the interior angle measures of any polygon. Okay. And what you should have figured out doing that Desmos together was that when we take a polygon, we can use diagonals from one vertex to cut it into triangles. So when I have triangle, of course I only have one triangle, and I know that one triangle is 180 degrees. Wonderful. When I take a quadrilateral, I can split it into two triangles. Each one is 180 degrees, so I get 360 degrees in a quadrilateral. In my pentagon, I can split it into 1, 2, 3 triangles. Each one gets 180, so I get 540. And pretty quickly, it's easy to see, hey, I'm just going up by 1 each time. And that number is always 2 less than the number of sides. And when I take that number of triangles times 180 degrees in each triangle, I get my formula. So I can use the formula n minus 2 times 180 to solve for the total sum of the angles in any polygon. So if I want to write that really fancily, and I do, I could say that the sum of the measures of the n interior angles of an n-gon is 180 times n minus 2, where n represents number of sides, or angles if I prefer to think of it that way. N minus 2 represents number of triangles formed. By my diagonals. And 180 comes from degrees in one triangle. So we're going to practice this a little bit. I'm asked to find the sum of an interior angle of a dodecagon. My dodecagon has 12 sides. So I'm taking my 180 times n minus 2 equals the sum of the interior angles, and I'm putting 12 in for n. So I'm going to have 180 times 12 minus 2, which is 180 times 10. So my final answer is 1,800 degrees. And number 2, I'm looking for the sum of interior angles of a 100-gon. Nothing changes, so friends. I'm still starting with my formula 180 times n minus 2 equals the sum of my interior angles. And then I can do 180. I'm putting 100 in for my number of sides. So I need to do 180 times 98. That is not something I can do in my head. Could, but probably not quickly enough. And I get 17,640 degrees in that polygon. I can also work backwards. I know the sum is 1,080, and I want to find the number of sides. So I'm still taking that formula. 180 times n minus 2 equals the sum of the interior angles. Instead of solving for the sum of interior, though, I'm solving for n this time. So I have 180 times n minus 2 equals 1,080. So I'm going to go ahead and maybe divide by 180. And I get n minus 2 equals 6. When I add 2 to both sides, n must be 8. If it's equiangular, I can take the sum and divide it by the number of sides. And I get what one angle must be. So I'm taking that exact same formula that was 180 times n minus 2. I'm saying, well, if I want to know what just one of them is, and they're all exactly the same, then I better just divide by n. So we're going to practice this a little bit. We know that each angle is 120, and we want to know how many sides. So I'm starting with that new formula we just found, 180 times n minus 2 over n equals 1 interior angle. And I know my interior angle is 120, so I'm going to do 180 times n minus 2 over n equals 120. I'm going to multiply by n on each side because that'll clear that fraction. And then I'm going to go ahead and distribute my 180. So my next line looks like 180n minus 360 equals 120n. Subtract 180n from each side and really watch those negatives. That's a 60. And when I divide negative 360 by negative 60, I get n is 6. Similar idea this time, that angle is 140. Okay, we're still going to work backwards though, so I'm still starting with 180 times n minus 2, all divided by n, equals 1 interior angle. This time though, I'm putting 140 in for my interior angle. I'm going to multiply both sides by n so that my fractions are cleared, and now I'm distributing my 180. So I have 180n minus 360 equals 140n. Subtract the 180n, and I have negative 360 equals negative 40n. And when I divide, I get n equals 9.